Okay, good afternoon. My name is Paul Oakley. I'm the Director for BIM at BRE. And I'm going to talk to you today about trying to deliver structured data and what I call about delivering a digital built Britain. And actually it's not just a digital built Britain, but a digital built Ireland, a digital built Europe, a digital built global solution. Because I've worked for years on projects or in particular sectors in terms of resolving the BIM projects. We've been able to do that, and I can show some of the things we've been doing at the BRE estate on these sorts of things. But really, it's how do we turn what we can do on specific projects into a global way of working for everybody. So there are digital drivers, and some of this has come up before. So the whole perception of BIM was it was going to sort this problem out of design and construction. And that there's this big area that we can resolve and there's big benefits. But as already been talked about today, it's not. That is tiny. When we compare that to operations, into business costs, business outcomes, the effect on a hospital of not having particular areas available for a number of hours is a problem. Weeks, months could be a major catastrophe. So actually looking at the effects of how we design, construct, the information flows is really what this is all about. And whether we like it or not, there is another basically change coming. The construction 4.1, we've all been talking about, we've seen it all over the couple of days. All these things are going on. We've got BRE site, we've got off-site fabrication, a drone flying over the BRE site, what we're doing with sensors, etc. These are not things which will be happening in the future. They are things that are happening now. And these are the drivers in terms of how we need to change. There's been lots of talk about digital twins, how we can have a real building and a virtual model and match those. And I'll talk about some of the things we've been playing with in relation to those later on. Now, whether you like it or not, COBie is a game changer. Within the UK, PAS 1192, we have a requirement for delivering proprietary file formats, PDFs, and COBie. So as a designer, I started off like this on the drawing board, paper deliverables. We moved into CAD, paper deliverables. We moved into BIM, paper deliverables. Coloured paper, flashier paper, paper deliverables. Suddenly, we have to deliver COBie, structured data. It's really important what designers, architects call stuff. The naming conventions. You can't just put random codes there because people need to be able to find things and understand what it is. All the tabs, the linking of things, the spaces, all those things are important because the information is going to be used downstream. Now the misconception we had that this thing was going to sort the problem out, the BIM object. We create BIM object libraries, we've resolved all of our issues. Then we can deal with the visualization, the graphical representations, and all the metadata. We put that in, solution solved. But there's a problem with that. My template was easy when I started off on the drawing board. This was it, every time, same solution. We get the BIM object. What is it? It's a piece of furniture. If anybody knows a software solution will actually realise that's a curtain wall. Not a problem if I'm producing a drawing, a visualisation model. If I need to deliver structured data, this is now a major problem. Because how this gets maintained, operated, it's in the wrong classifications, etc. So that's what it would normally look like before I played with a few variables. Out of the software, half hour, 1 hour, 2 hour walls. They all use the same plasterboard material. You cannot get that performance out of those objects. Just because the software happens to name those things that way doesn't mean that they physically perform that way. And when you start looking at what you really need, there's all sorts of issues in terms of how we manage the flow of the data through the models and the process. Symbology. Quick show of hands. How many people think that's top hung? Few, okay. BS 8541-2, top hung. The rest of you must be Australian, because in Australia, that's bottom hung. So the same symbology means completely the opposite depending on where you are in the world. And as American Hospital, several million pounds worth of dollars worth of windows that needed to be replaced because they're all put in upside down because this wasn't resolved. Naming conventions, different with different software. You can have variable thickness elements, non-variable thickness, depending on what solutions you're using. So how you name the stuff to go into COBE becomes a problem. And then we get down to the real basics. If we want to pass information from manufacturers' websites to our objects, what do we call the two sides of a rectangle? How can we pass two consistent variables so we can drive geometry to get the solutions we need? When we're going to replace one thing for another, can we pass that? So are we calling it AB, X, Y, length, breadth, depth? We can't make decisions on these basic things. Then you go into the likes of Revit, and actually they're case sensitive, or you want to grab your own ownership, or you can't spell. We get all these issues in terms of delivering structured data. So I mentioned about the BIM objects, and the problem we have in the UK is there's lots of people doing it. They're all doing it differently, and therefore trying to extract the data in a consistent manner is very, very difficult. So using Revit, I put a window in, well, 4 windows into a wall, and we have an acoustic rating variable. I gave it 27 decibels. I then added in a National BIM Library object. They have a string value telling you about acoustic rating. BIM Store have a formula on how they calculate acoustic rating. BIM Object only got acoustic, they can't afford the rating, but they have a URL. We have 4 separate streams of data. Which one of those 4 are you going to extract out to COBE? Or has somebody manually got to go through the different windows and put those into the right formats and add the right levels of measurements? Typical objects. Now, I picked on National BIM Library, but in my view, they're probably the best. Okay? So I picked on them, but graphical data. There's a sheet of information, and another sheet, and another sheet, and another sheet, and another sheet, and another sheet. This is all the information on one window. Do any of those windows have the size of the glass? No. How can I calculate how much daylight comes through that window? How can I automate BREAM, which is one of the BRE products, to deliver the amount of light coming through there? How can I work out the ventilation? How can I work out the guy going there to replace the glass, what size of glass does he need? We don't have the basic information that we need on these things. So the problem that we've got at the moment is everybody's tried to put everything onto the BIM object, where we need to start referencing information. And it's great to see that MBS are now moving into a cloud-based solution where you can start using APIs and referencing and cross-referencing things. And we need to, if we're going to get access data onto mobile devices, etc., we need to use these technologies, not trying to pull everything down onto one model and hold it on the object there. But this is going to allow the industry to move forward and sort these problems out. We've also got a look at the data solutions. This is some of the work we've been doing at the BRE. That you need standardized data templates, a single source definition of that truth. That you agree all of your attributes, you group them into property sets, you associate those with objects. So we can deliver the information from those who want it to those who have it in a consistent format. We can verify it, we can check it, we can ensure that what is delivered meets our requirements. So we've been developing this tool, the templator. We have various versions, and at the moment most of it's just published with the IFC data, because that's the only consistent published data standard out there. But we're using it on various Horizon 2020 projects, also looking at life cycle of construction, etc. But the way that works is we have groupings, property sets associated with templates linked to categories of objects. They all have a human readable version, down to a database, down to a CAD. So you can translate between the three depending on how you want to view the information. And then each one has its own units of measurements. It comes from a common attribute, and it has a reference in terms of where the thing is actually used. As I said, we've populated with the IFC, so you can go in, and this is all based on APIs. You can pull the data in solutions and deal with it. And on the back of this, we've built on the ecosystem. So we have the templator, and then we have something called data book. So manufacturers can publish their data against that template. Now, BRE's business is not creating BIM objects. Now, we're looking at manufacturers working with the likes of MBS in terms of carrying out that work, but we're just hosting the published data. So there's a single source in perpetuity. So even when the products are no longer available, the asset management solutions, facilities management, as well as designers can access this information. And the sort of work BRE does in terms of looking at 5, 10, 15, 20-year performance of buildings, we can do based on that data. And then we have plugins for the likes of Revit. So the linking between the BIM objects and data book can happen. Then suddenly COBE can become effective. We can get consistent delivery of information, and that can then be linked into web tools. There's a Forge viewer through an FM system, which can then link back to the original data book data. So suddenly we change the whole landscape, the whole way this is all going to work. We can license the data, have a central repository that we're all using to meet our requirements. So some of the work we've been using at BRE, my whole sort of ethos is if we can't do it, we shouldn't preach about it. So when I joined the BRE, I said, right, we're going to build a digital estate, so we're going to go through all our buildings, we're going to build the BIM models. And I went in, looked at the drawings. This is a 1970s building. You can see it's stamped tender. This is what our FM teams were using. And then somebody had done some basic plans. We had a site plan, flat 2D site plan, but they had points. I could do it was 10,000 points on this site. I was going to give a student time to actually create the 3D solution. Then actually, we can just extract that with a bit of code, and we can create a full topo surface. We can start to build up each of the buildings on our site. So I've had some students, part of my team. We trained them on how to model using the solutions, and then we tied that using Sensat, did some drone surveys, and actually realised what we were producing was actually pretty accurate to within a couple of inches. We've got 3D spin arounds and the flashy visuals, and we can do that. But more importantly, we have structured data on them. So the spaces, the objects, the things have the data that we can then use in the research projects we need to carry out. So we can then take those into FM solutions, and they can validate that the information meets the requirements. They can do it in a 2D format, they can view it, they can get space information. They can take it into the Forge viewers and validate the information. And they can then look at all the tagging and how we link to our data book project and bring all this together. Now, I mentioned about the digital twin. So we had physical and the BIM stuff. So this the integer house, as you come into the BRE, is our smart home. It's just full of all these sensors and all sorts of things going on. And any smart technology is being used within that building. And suddenly we looked at how we could basically bring those two things together. So this is their view of that house, okay, and how the smart team look at the stuff. So we said, actually, we can create BIM objects. We can use our templator to define standardized data templates on those. And we can agree that flow of information. And then we can use Dynamo through Revit and other solutions to play with the stuff. And wrote .NET bit to read the information from the sensors, and we then had issues in terms of how do you number and name the sensors and deal with the timelining and all those sorts of things. But that allowed us to then grid up the floor, and then we could show the sensor information through the course of a day. If you're watching the sort of conservatory area, suddenly it gets very, very hot and above design temperatures as that goes through a period of time. And then we looked at actually, what if we take that further? What if we take our main office building? If we fill that whole thing with sensors that don't just deal with one thing, but temperature, luminance, humidity, even motion, and we apply the same process, that suddenly we can start getting back all this data relating to usage on those buildings. But then actually displaying it like that isn't very useful to us. But we know how to model, we know how to create things like light sources in Revit. So basically we turned each of the sensors into a light source. And then we applied the colours related to values from the sensors to the light sources. So then we could show the illuminance in light. We could show the humidity using light colours. We could show the temperature using light. But we don't just want static views. We want to be able to interact with the information. So we pop this into the Unity gaming engine so we can start moving around the building and start reading the sensor information as you're moving around through the model. And you can see as we start to zoom in, we threw the sensor data a bit quicker because it was a bit too static for what we wanted to present. But it allowed us to basically move in to particular rooms. You can see the different sensors as we go up through the floors. You'll see different values coming in. But all this is available with general technology that anybody can get hold of and use. We also have a circular economy project, which is called BAM, or Buildings and Material Banks. So this is how we're looking at the whole life cycle approach to data. So there's talk about 5D yesterday, how you construct things. This is looking at how you deconstruct. How do you take the buildings down? How can you reuse the materials, which may not have spent their, they might not have filled their lifetime, or the building might be taken down after 15 years, but the materials are available for 50 years. So in terms of delivering a digital built Britain, there's loads of stuff that can be done. But there's lots of basic things that need to be sorted out. These basic structure things, education and modelling, that we need to resolve. Okay, so just something slightly different. You may have heard of this. Okay? It's not a BRE product. Okay? It's nothing to do with us. But it has an advantage. So the BRE do a lot of certification across Europe. And due to Brexit, we need to have a location within Europe. So we've opened a Dublin office. There's over £3 million investment being proposed for Dublin in terms of developing BRE's presence within the Dublin area, with all our certification testing coming in to Dublin. And John there is our local contact in terms of driving the things there. In terms of the BIM stuff, I head up the BIM technical team. We have lots of advisory services. We work with industry in terms of helping promote standards, etc. We have the education through the BRE Academy and certification through Global. Anybody wants to work with us on research, we've got the work we've been doing on our estate that can be used as a test bed for things. So we're quite happy to work with industry on these things. The other thing I'd like to announce that's come out today is basically the partnership between BRE and CitA in terms of how we're looking to take the training and education forward within Ireland. And that will be developing, as the ISO comes out, we'll be supporting on the training and education with that pathway. So, thank you very much for listening. I hope you found it useful. Okay.